Hello everyone. In this lecture of the Essential Calculus Problems series, we will solve the integral of sec³ x dx. Let's write the integral again. The integral of sec³ x dx. In order to solve this problem, we will use integration by parts. And for doing this, we will write the integral again as sec(x) times sec² of x dx. We know that the derivative of tangent x is equal to sec² of x. You should know this for this problem. Then here we will say that, let me remind you the integration by parts. If we have an integral such as integral of u times dv, here we have u is a function of x and v is another function of x, then this integral will be equal to u times v minus integral of v times du. We will use this to solve the integral here. Here we will say that sec(x) is u, and since we know that the derivative of tangent x is sec² of x, we will say here dv. Okay. And sec(x) is equal to u. Then the derivative of sec(x) is sec(x) times tangent x, and times dx will be equal to du. And tangent square of x dx is equal to dv. This means that tangent x is equal to v. Take these two. Okay, these two are important. Now our integral was sec³ x dx, and this will be equal to u times v. U is here sec(x), v here is tangent x, sec(x) times tangent x minus integral of v du. V here is tangent x, and du here is this sec(x) tangent x dx. Let's write it. Sec(x) times tangent x. This means that tangent x multiplied by tangent x, we will say here tangent square of x dx. Then we should also know that tangent square of x is equal to sec² of x minus 1. And if you forget this, then you should write tangent square of x as tangent square of x is equal to sine square of x over cosine square of x. And since cosine square of x plus sine square of x is equal to 1, we can rewrite sine square of x as 1 minus cosine square of x. Then this will be equal to 1 over cosine square of x minus cosine square of x over cosine square of x. And 1 over cosine x is sec(x), so 1 over cosine square of x is sec² of x. And cosine square of x divided by cosine square of x is equal to 1. This means that tangent square of x is equal to sec² of x minus 1. And here in the integral, I will rewrite tangent square of x as sec² of x minus 1. Then the integral becomes, our integral was sec² of x, sec³ x dx, and this will be equal to sec(x) times tangent x minus the integral of sec² of x minus 1 times sec(x) dx. Now we will, okay, let me add a page here. Okay, and now we will multiply sec(x) by them one by one. Okay, let's take s down. The integral secant x times secant square of x is equal to secant cube x, and secant x minus 1 and is equal to minus secant x dx. We can split this integral into two parts, and I will do it. Take this down again. Minus secant cube x dx, and minus secant x is equal to plus secant x. Plus integral secant x dx. As you can see that our integral was secant cube x dx, and we have here secant cube x dx again. Then I will take this to the left side of the equation, and then we will get 2 times integral of secant cube x dx will be equal to secant x times tangent x plus integral of secant x dx. Actually, before this video I solved the integral of secant x dx, and integral of secant x dx was equal to ln absolute value of secant x plus tangent x. So you can see it. You can see how we solve this integral of secant x before by looking at the integral of secant x video. And as you see, secant cube x dx will be equal to secant x times tangent x plus ln secant x plus tangent x divided by 2. But in this video I will show you how we will solve secant x dx again. Okay, let me solve the integral of secant x dx is equal to integral of secant x times secant x plus tangent x divided by secant x plus tangent x. This way, that multiplying by secant x plus tangent x and dividing by secant x plus tangent x is most used method. And why are we doing this? You will see as after we multiplied by secant x plus tangent x. Okay, the integral becomes secant square of x plus secant x times tangent x divided by secant x plus tangent x dx. We know that the derivative of secant x is secant x times tangent x, and also we know that the derivative of tangent x is tangent square of x. Then we can use substitution method here. We will say that secant x plus tangent x is u. Let secant x plus tangent x equals to u. Then take the derivatives. Derivative of secant x is secant x times tangent x, and derivative of tangent x is secant square of x times dx is equal to u. This means that here we have du, and this part at the bottom will be u. Then the integral becomes integral of 1 over u times du. The integral of 1 over u is ln absolute value of u. And we said that secant x plus tangent x was u, then this integral becomes ln absolute value of secant x plus tangent x. So in this part, in this integral, we will write here ln absolute value of secant x plus tangent x. So the integral becomes 2 times integral of secant cube x dx will be equal to what? Will be equal to secant x tangent x plus ln absolute value of ln secant x plus tangent x. Then take these two as division to the here. Then the integral of secant cube x dx will be equal to 1 over 2 secant x tangent x plus 1 over 2 times ln absolute value of secant x plus tangent x. And since the integral is an indefinite integral, we add a constant c here. And the answer is this. In the next video, we will solve the integral of secant to the power of 4x dx. See you in the next video.